Assalamualaikum. I'm Nusrajan Faria. My ID last 3 digit is 650. Respected star and everyone present here. We are group 4 and today we are here to present our project on multi-class gesture recognition using sensor data. We are a group of 5 members and we have divided the whole project into different parts. So today we will take you through our complete process starting from the data set, then the data analysis and pre-processing, feature selection, model training, and finally the results and conclusion. So let's start with the basic idea of our project. Next. Next. First, let's talk about what we are actually trying to do in this project. The main question we wanted to answer is, can we use sensor data to identify which gesture a person is performing? To do this, we have different types of sensor measurements as our input. This include rotation, thermal, orientation, and time of flight data. Based on this sensor reading, our model tries to predict which one of the 18 different gesture classes the observation belongs to. So, in a simple way, we can say that sensors measurements are our input, and the predicted gesture is our output. To complete the project, we followed a few important steps. These are: the first thing is we understood the data set, then we performed EDA to see how our data looked and how the features are related. After that, we selected the most useful features and performed the necessary data preprocessing. Then we trained our machine learning models and finally we compared those models to see which one performed better. So this is basically the overall journey of our project. Next slide. Now let's have a look of our dataset. Our dataset is quite large. It contains around 5,74,945 observations and 341 columns. Out of these columns, 333 are numerical features and we have 18 different gesture classes. Later, after feature selection, we kept the top 70 predictors that were considered useful for our modeling. Now, if we look at the sensor group, there are mainly four types. Rho, that is represents the rotational for movement or movement related measurements. THM, that represents the thermal measurements, basically the temperature related information. And then we have TOP, which stands for time of flight and gives us distance related measurement. And finally, ORI, which represents the orientation information. So basically our model gets information from these different sensors and tries to understand the pattern behind them. And based on those patterns, it predicts which gesture the person is performing out of the 18 possible gesture classes. So in short, this is a multi-class classification problem because instead of predicting the two outcomes, our model has to choose from 18 different classes. That's all from my part. Now I would like to hand over the presentation to our next member.
Assalamu alaikum everyone. I am Mushammad Shadia Khatun. My ID last 3 digit 069. Next slide. Now I would like to present the exploratory data analysis or EDA part of our project. In this stage, we explored our sensor data to understand its overall patterns and characteristics. First, we performed univariate analysis, where we analyzed individual features to understand their distributions and variations. Next, we performed bivariate analysis to examine the relationship between two features using scatter plots and regressions line. Finally, we used multivariate analysis and pair plots to observe the relationship among multiple sensor features. Overall, this EDA process helped us understand our data better before moving to the pre-processing stage. Now let's move to the feature distributions and outlier analysis. Please move to next slide. In this slide, we analyze the distributions of our selected sensor features and identified possible outliers. The histogram helps us understand how the values of different features are distributed. while the box plot helps us identify extreme or unusual values. Instead of completely removing these outliers, we use IQ or capping. This method reduces the impact of extreme values while keeping most of the useful data. As a result, our data become more balanced and suitable for further analysis. After handling the outliers, we move to correlation and missing value analysis. Please move to next slide. In this final step, we perform correlation analysis and handle the missing values. The correlation analysis helps us understand the relationship between different sensor features, among them THM1 and THM2 show the strongest positive correlation with a value of approximately 0.731. For missing value, we remove 12,341 incomplete observation using NA.omit and retain 5,62,604 complete observation. This means only around 2.15% of the original data was removed. So after completing EDA handling outliers, analyzing correlations and treating missing values, our dataset becomes cleaner and ready for the next stage of our machine learning workflow. Thank you.
Hello everyone, Assalamu alaikum. This is Abdullah Mujahid, last 4 digit of my ID 1508. Now let's talk about feature selection. Our dataset had 333 numerical features. Using all of them is not always a good idea. So we use information gain to find the features that are most useful for recognizing gestures. Simplify information gain tell us which feature give the model more useful information. From the 333 features, we select the top 70 features. We also noticed that row ID and sequence ID had very high score, but these are only IDs, not real sensor information. So we remove them to avoid data leakage. Now let's see how we prepare the final data set. Our dataset had 574,000 rows and 341 columns. Then we selected the top 70 features, remove rows with missing values and handle extreme value using IQR outlier capping. After that, we remove row ID, sequence ID and ID because they are just identifiers. Finally, we got 562,000 clean observes for our machine learning models. So our data was clean and ready for modeling. Next, we divided this data into three parts. We divided the data into three groups: training, validation and testing. 70% data we use for training. This is where the model learns patterns. 15% data we use for validation. This helps us check and improve the model. The final 15% data we use for testing. This data was kept separate to check the model's final performance. So after preparing and splitting the data, we are ready to training our machine learning models. That's all about me. Now my teammate Lubna present her part of this presentation.
Thank you, Abdullah Al Mujahid. Assalamu alaikum, everyone. My name is Lubna Parvin. My ID is last 4 digit 1162. In the next few minutes, I'll be presenting about machine learning models, model configuration, and evaluation metrics. Now, I will discuss the machine learning models we used in our project. We compared two tree-based example models, XGBoost and Random Forest. XGBoost is a boosting technique where trees are built sequentially. Each new tree tries to correct the errors made by the previous trees, so it gradually improves the prediction performance. On the other hand, Random Forest uses a bagging approach. It builds many decision trees independently using random samples and random subsets of features. Finally, the prediction from all the trees are combined using majority voting. We select these two models because they are well suited for our high dimensional sensor dataset. Move to next slide, please. Here, we can see the main configuration of our two models. For XGBoost, we used the multi-softmax objective because our problem has 18 gesture classes. The learning rate was 0.05. Maximum tree depth was 8 and the subsample value was 0.8. We trained the model for up to 500 boosting rounds, with early stopping after 30 rounds without improvement. For random forest, we used 270 trees with empty try equal to 8, meaning 8 variables were considered at each split. The node size was set to 1. This configuration allowed us to train and compare both models fairly on the same gesture recognition problem. Move to next slide, please. Before discussing the final results, we need to understand how we evaluate our models. First, accuracy represents the percentage of total predictions that were correct. Precisions tell us when the model predicts a particular gesture, how often that prediction is actually correct. Recall tell us how many of the actual cases of a gesture were successfully identified by the model. F1 score combines precision and recall into a single balanced measure. Finally, we used the confusion matrix, which helps us see which gesture classes are being confused with each other. We applied this matrix to evaluate both XGBoost and random forest on the validation and test sets. That's all from my part. Now, I would like to hand over the presentation to the next teammates. Thank you.
Thank you, Lubna Parveen. Assalamu alaikum. I am Nafizul Islam Fuad. Last 4 digit of my ID is 1466. My topic starts from here, the model performance comparison. Now let's look at the final result of our two models. On the test dataset, XGBoost achieved 74.27% accuracy, while the random forest achieved 82.99% accuracy. Random forest also performed better in the other metrics, like as the precision was 85.25, recall was 82.24, and the F1 score was 83.47%. Compared the XGBoost, random forest improved the accuracy by 8.72 percentage point. So based on accuracy, precision, recall, and F1 score, random forest clearly performed better than the XGBoost. The next slide. The best model. Therefore, our best performing model is the random forest. It achieved 82.99% test accuracy with 85.25% precision, 82.24% recall, and 83.47% F1 score. Another important point is the validation and test performance. The validation accuracy was 82.95%, while the test accuracy was 82.94%. The difference is only 0.04 percentage point, which show that the model performance vary consistently on unseen data. Next slide. Conclusion, limitation, and the future work. To conclude, we started with 5,74,945 observations and 80 gestures classes. We reduced the 333 numerical predictors to 70 features using information gain. After cleaning, we had 5,62,604 observations, which are divided into 70% training, 15% validation, and 15% testing. We compared two machine learning models, XGBoost and Random Forest, and Random Forest achieved the best test accuracy of 82.99%. However, our project has some limitations. We used fixed model settings instead of symmetric hyperparameter tuning. And we did not separately establish subject level or sequence level independence. We also compare only two final classes. For future work, We can perform hyperparameter tuning, use subject-aware and sequence-aware validation, apply explainable AI like SHARP, Liam, and compare additional models such as LightGBM, CatBoost, SVM, and neural network. Thank you. That's all from us.